27,000 robots every single day. From one factory still under construction. That's 14 times what Toyota builds at its largest plant on Earth. And it's not cars. It's humanoid robots, priced at $20,000 each, less than a used car. In June 2026, Elon Musk didn't announce this. He poured the concrete. And today, we're going to walk through exactly what that means for every worker on the planet. To understand what 27,000 robots per day actually means, you need a benchmark that makes the scale tangible. Toyota's Georgetown plant in Kentucky is one of the most efficient vehicle manufacturing facilities ever built. At full capacity, it ships roughly 550,000 cars per year, approximately 1,500 to 2,000 vehicles on a strong production day. It is considered a masterpiece of modern industrial engineering. Tesla's Optimus North campus is targeting nearly 14 times that daily output. Not 14% more, 14 times more. From a facility that, as of mid-2026, is still structural steel rising out of the Texas ground. The facility itself spans more than 5.2 million square meters. Tesla has committed between $5 and $10 billion to construction alone. The stated production goal, 10 million robots per year by 2020. When you translate that target into economic terms, you are not looking at a factory. You are looking at the potential deployment of a new category of labor, non-human, tireless, and priced, according to current estimates, at around $20,000 per unit. The obvious question is whether that number is real or whether it is a projection engineered to generate headlines and hold investor attention. The honest answer is that it is both, and the distinction between those two things is exactly where most analysis gets it wrong. Before a single Optimus V4 rolls off the Texas line, Tesla made a decision in early 2026 that received almost no serious coverage relative to its strategic weight. Tesla halted production of the Model S and Model X at its Fremont, California facility. These were not fringe products. The Model S was the car that defined Tesla as a serious automaker. It was the machine that put the company on the map, fast, beautiful, and electric, at a time when no one believed those three things could coexist. Killing its production line was not a routine operational adjustment. According to analyst estimates, Tesla walked away from hundreds of millions of dollars in annual contribution margin to do something more valuable: convert Fremont into a manufacturing laboratory for humanoid robot production. The Optimus Gen 3 line at Fremont went live on January 21, 2026. But Fremont was never meant to be a robot factory at scale. It was meant to be a data collection engine. Every misaligned grip, every torque inconsistency, every failed inspection, all of it feeds directly into the design architecture of the Texas production system. Tesla calls this approach internally: validate at Fremont, replicate at Giga Texas. This matters because what ships from Texas will not be the robot running at Fremont. The Optimus V4 is a complete generational redesign. Every joint, every actuator, every sensor cluster has been re-engineered around a single constraint: the ability to be manufactured at industrial scale. V3 exists to teach, V4 exists to deploy. Construction at North Campus began in November 2025 with standard site preparation, the kind of groundwork that rarely attracts attention. But in April 2026, engineers following the project noticed something that signaled this was not standard construction practice. A company called GeoPier appeared on site. Their technology, Rammed Aggregate Pier Systems, or RAP, does not drive conventional concrete piles vertically into the earth. Instead, it creates a dense grid of compressed aggregate columns that dramatically increase the load-bearing capacity of the surrounding soil before primary concrete foundations are poured. Independent data from GeoPier indicates the technique reduces foundation construction time by 20 to 40% versus traditional pile driving. Why does foundation engineering matter for a robot factory? Because the geological profile beneath the Austin region contains expansive clay soils, ground that shifts as moisture levels change across seasons. A facility spanning more than 5 million square meters, running precision robotic assembly at tolerances measured in micrometers, cannot tolerate uneven foundation settlement over years of continuous operation. Tesla did not take a shortcut at the ground level. They chose the fastest available method that still guarantees structural stability across decades. By late May 2026, prefabricated steel columns began arriving on site, each component fabricated off-site to exact specifications and transported for rapid on-location assembly. The contractor executing the steelwork is the same team that built Giga Texas, 4 stories of framing in under 3 weeks. By end of 2020, the building is projected to reach full structural enclosure, with industrial electrical systems rated at up to 500 megawatts of capacity, equivalent to the electricity consumption of roughly 400,000 American households, allocated not to lighting but to simultaneous robot production and on-site AI computing. Here is what the steel frame footage does not show you. Between the structure rising in Texas and the achievement of 27,000 robots per day lies a set of engineering challenges that have never been solved at any scale, anywhere in manufacturing history. The first is quality inspection. When Toyota ships 2,000 Camrys per day, end-of-line inspection is well understood. Brake function, engine output, electrical systems, a defined checklist executed across parallel stations in roughly 4 to 6 minutes per vehicle. An Optimus V4 is a fundamentally different verification problem. Each unit requires hardware confirmation across more than 40 independent joints, plus AI validation. Does it interpret commands correctly? Does it respond safely to unscripted scenarios? Is it safe to operate alongside humans without supervision? If a conservative inspection methodology requires 2 hours per unit, 27,000 units per day demands 50,000 inspection hours daily. That number collapses under its own weight. Tesla must invent a system where AI validates AI in real time without slowing the line. The second is supply chain. A single Optimus V4 requires between 30 and 40 strain wave gear assemblies. The precision actuators that give robot joints their torque characteristics. 10 million robots per year requires between 300 and 400 million of those components annually. The combined output of the world's leading harmonic drive manufacturers does not currently approach 1% of that requirement. The component supply chain for humanoid robots at this scale does not yet exist. A significant portion of Tesla's $20 billion 2026 capital expenditure is directed not at the Texas facility itself, but at building new industrial manufacturing capacity for components where no supplier currently operates at the required volume. The third problem is the one no one is discussing. Every robot leaving the Texas line must receive the current AI model build, be calibrated to its own individual hardware parameters, because no 2 units are physically identical at the micro level, and be validated for software-hardware synchronization before it clears the facility. Embedding that sequence within a continuous production flow at full throughput, without creating a bottleneck at the firmware integration stage, is a problem with no precedent in manufacturing history. It must be solved before summer 2027. Tesla's realistic production trajectory, based on its own manufacturing track record across Giga Texas and Giga Berlin, looks like this. By summer 2027, the first Texas production line achieves operational status with initial output measured in hundreds to low thousands of units per day, delivered primarily to enterprise partners for continued real-world data accumulation. Through late 2007 and into 2028, output scales as manufacturing processes are progressively optimized, and robots begin entering commercial markets at an estimated price between $20,000 and $30,000. From 2029 onward, if the 3 core technical constraints have been resolved, the line approaches its rated capacity. For context, Giga Texas went from cleared ground to shipping Model Y in 18 months during a global pandemic with supply chains in crisis. Giga Berlin took approximately 24 months, delayed by European regulatory complexity. North Campus is currently tracking at the pace of Giga Texas with none of those external disruptions. The steel frame documented on June 17, 2026, is not a rendering. It is poured concrete and fabricated steel, representing a $10 billion physical commitment to something the world still largely treats as science fiction. Which brings the conversation to where it actually matters. When Optimus V4 reaches commercial availability at $20,000, the price of an entry-level used car, accessible to any business operating on a standard credit line, 2 futures become simultaneously plausible. For aging economies across Japan, South Korea, and much of Europe, where the working-age population is contracting and elder care costs are approaching fiscal crisis, a robot that can operate reliably in homes and healthcare environments may represent a genuine structural solution for the hundreds of millions of workers in logistics, light manufacturing, and service industries. People in their 40s and 50s who built careers around physical labor. The arrival of that same robot at that price point is not an opportunity. It is a displacement event they did not see coming and have no roadmap to navigate. At $20,000, the Optimus V4 becomes the most consequential product launch in modern industrial history. Not because of what it does, but because of what it replaces. The largest robot factory ever built is under construction right now. The question it forces on the global economy is not a technical one. It is a human one. And the answer is not going to come from the factory floor.